Okay, so this is the introduction of theory of structures. So let us discuss the basic concept of structural engineering or structural analysis. So if you are to recall from your statics, the basic concept, if we have simple structures and you are to do force analysis, so basically the purpose of structure is to carry loads to resist forces. If you are to do force analysis from your statics, you can do this you can use the three equations of equilibrium if you are dealing with simple structures. So what are the three equations of equilibrium? Summation of forces horizontal equal to 0, okay, summation forces vertical equal to 0, and the summation of moments equal to 0. Okay, for this term, we are to discuss the three main types or three common types of structures. So what are the three main common types of structures or structural member? Okay, we have the beam. Okay, any horizontal member, they are used to carry transverse loads. We have the truss and the frame. Okay, so they are all throughout this course or this subject, we are to discuss the force analysis of beams, truss, and frame. Okay, so before we proceed to the actual analysis of beam, truss, and frame, let us discuss their stability and indeterminacy or determinacy. It depends sometimes on their types of support. So there are several types of supports for structure. Okay, kaya lang, what are the three main common types of structures that are around us? We have the first one is, for example, this is a beam. So one common type of support is we have the ruler. So it doesn't mean naman na it is a rounded object or a rounded support. Anything that is, or if you are to just to place the structure over a support, that is considered to be a ruler. And the number of reactions for a ruler is, we have the number of reactions is simply equal to 1. Then the next type is we have, for example, this is your beam, and it is fastened at exactly, let's say, 1 point. Okay, we have a fastener, and this beam is free to rotate. This is a hinge. So we have, for a hinge, we have two reactions, horizontal and vertical. So the number of reactions will be equal to 2. The third common type of support, okay, we have, for example, this is a beam, usually. A basic example lang nito is we have concrete beams, or that is the joint of a beam and a column that is considered to be fixed support. So for a fixed support, we have vertical reaction, horizontal, and the moment. So the number of reactions we have 3. So those are the three main or common types of reactions. So other than this, we have the cables, or that is the connection of the cable to its support, the link, and so on. I think that is available in your module. So let us discuss first stability and determinacy for beam. Okay, so this is stability and determinacy of structure. So if we say stable, we may say that a structure is stable if you are to base just on reactions. We have enough number of reactions. Okay, so we have enough number of reactions to carry the load. Then the structure will not, the structure can resist or carry the loads without moving. We are just to consider as statics. Then we have determinacy. We may say that a structure is determinate. Okay? A structure is determinate if we can be analyzed using statics. Alright, so if we say statics, you can use the three equations of equilibrium. Okay? So determinate structures can be analyzed using statics, the three equations of equilibrium, the summation of moment, summation of forces vertical, and the summation of forces horizontal. So basically, which means you have enough number of equations to compute for the reactions or forces. Kapag indeterminate naman, okay, obviously, for indeterminate structures, your equations is, the number of equation is inadequate to compute for those forces. So you need special procedure or special type of equation to solve for those unknowns. I will proceed to beam. And the corresponding criterion to identify whether a given beam is unstable, determinate, or indeterminate. So we have a beam can be unstable if we have the number of reactions is less than the factor C plus 3. So we will discuss this factor C later on. So a beam can be determinate. A beam is determinate if the number of reactions basically equal to C plus 3. Then we have indeterminate if the number of reactions is greater than C plus 3. So usually if you are to do structural analysis of beams, first thing to do, you are to compute for the support reactions. Now, if the three equations of equilibrium is not enough, you have more than 3 unknowns, which means you are lacking with equations. So you need another special equation or special procedure. So we have for the factor C, okay, the value of C is equal to 1 if we have an internal pin or internal hinge. So for example, sa beam, for example, we have this symbol or parang dot lang siya. Is a dot on a beam that is considered to be an internal pin or an internal hinge. We have the value of C is equal to 2 for the case of internal ruler. If we have an internal ruler, for example, we have this one. So we have 6 equal to 2 for the case of internal ruler. So let's have an example. Okay, so our example, I classify the following beams. So we have the first one. So we have a hinge support and a ruler support. So how many reactions for a ruler? We have 1 reaction. For a hinge, we have 2. So this beam can resist horizontal force and at the same time vertical force. So we have the value of number of reactions is equal to, we have 3 reactions. We don't have an internal pin or an internal ruler. The value of C is 0. So obviously, if you are to follow the equation R, is it less than, equal to, or greater than C plus 3? The number of reactions is 3. We have 0. I think this is equal plus 3. So you have 3 is equal to 3. So this is considered to be a determinate beam. Usually kapag sinabing determinate beam or simple beam, you have 1 hinge support and 1 ruler support. Therefore, it is a determinate beam. Then number 2, okay, we have, this is a hinge support, a ruler, and a fixed support. For a hinge, we have 2 reactions. For a ruler, we have 1. For a fixed support, we have 3. Vertical, horizontal, and a moment. So how many reactions in all? We have 1, 2, 3, 4. 5. We have 6. Okay, 6 reactions. And then, again, we don't have an internal pin or an internal ruler. So we have the value of C will be equal to 0. So we have the equation R, is it greater than, equal to, or less than C plus 3? Number of reactions, we have 6 is obviously greater than 3. So again, the number of reactions is greater than 3. So we may consider this structure as indeterminate. And this beam is indeterminate. Kung tatanungin, if you are asked, what is the degree of indeterminacy? That is basically the difference of these 2. The degree of indeterminacy is 6 minus 3. It is indeterminate to the 3rd degree. So which means, di ba, if you are to recall the three equations of equilibrium, we have only three equations. We are lacking with three equations. To solve for these reactions or for these unknown forces. So the summation of forces vertical, summation of moment, summation of forces horizontal, yung three equations na yun will be not enough to compute for those unknowns. Okay, then next one. Example number 3. Okay, how many reactions do we have? For a hinge, we have 1, 2, 3, and 4. So we have the number of reactions, we have 4. What is the value of C? We have an internal ruler. For an internal ruler, we have the value of C to be equal to 2. So we have, this is, the number of reaction is 4. That is obviously less than the value of C, 2 plus 3. So you have 4 is less than 5. So this structure is considered to be unstable. Okay? So unstable. Okay, so bakit siya unstable? How about this one? Can we consider this one as stable? Yes, it is stable. It can resist horizontal loading since we have a horizontal reaction and vertical reactions. But for this case, kung i-observe lang yung portion na to, they are both ruler. So the disadvantage of a ruler, it cannot resist horizontal force. For example, we have a horizontal force here. Obviously, since they are ruler, this beam will move to the left. This, for example. So it is unstable. To make this stable, I think you may replace this ruler with a hinge. Pwede niyong palitan. And then we have this one. For example, we have both ends are fixed. How many reactions? So for a fixed support, we have 3 reactions at both ends. So we have the number of reactions will be equal to 6. Okay? So 3 on each side. We have 2. Okay, tingnan tayo ito. Meron tayong dalawang internal pin. So it makes the value of C, 1 for this pin, plus 1 for this pin. The value of C will be equal to 2. Okay, so if we are now to check the number of reactions, I think this is greater than the value of C is 2 plus 3. So 6 is greater than 5. The degree of indeterminacy is the difference of the two, 6 minus 5, that is first degree. Yeah. Kumbaga, kulang lang tayo ng isang equation. We are lacking with one equation to compute these 6 reactions. So you are to use another or special procedure or special equation to solve for the unknown. And then we have next, number 5. For number 5, for example, we have these types of support. Take note if you are to see this symbol, kapag nakita niyo yung mga symbols na to, they are also considered as rulers. Okay? So let's say this is the ruler on this end, another ruler on this end. If we are to, for example, consider the direction of this reaction and this reaction of this ruler in the middle, and they are to meet on this point A. So that makes these 3 forces are considered to be concurrent. Okay, if they are concurrent, they are to meet at one point. So is it stable or unstable? If we are to check the number of reactions is 3. The value of C is equal to 0 since we don't have an internal ruler or an internal pin. Okay, so that makes 3 is equal to 0 plus 3. So we have 3 is equal to 3. Can we consider this one as determinate, unstable, or indeterminate? Okay, basically, if we have concurrent forces, take note that this is unstable. Okay? Kung magde-design kayo, avoid having that type of designs that your reactions, or the direction of your reactions will meet at one point. Bakit yun? If we are to place a load here, and if I to do summation of moment, for example, if I to do summation moment about point A equal to 0, ano mangyayari? We have a force here, for example. So if this force, we don't have any resisting moments to prevent this force, since ma-cancel the moment of this reaction and the moment of this reaction. The same with this reaction will be cancelled since you are doing summation moment about A. So summation moment about A. So ang mangyayari, this one will slide down to the right. Ito naman, slide down upward to the right. That makes it unstable. Okay, take note, if you are to design, avoid having concurrent forces or concurrent reactions. And the last one, kanina, yung binula ko dito, ito ko lang ilagay. Okay, for this, we have 3 rulers. If you are to follow, again, the rule, we have the number of reactions is equal to 3. We have the number value of C is 0 since we don't have an internal pin or an internal ruler. So again, we are to satisfy 3 is equal to 0 plus 3. So 3 is equal to 3. But since they are all a ruler, the same with this one, kanina. If we are to apply a horizontal force F, this beam will move to the left. That makes it unstable. Okay? So it is unstable. Okay? So what causes unstable beams? So una, kanina, why is it unstable? You have concurrent reactions. Okay? So concurrent reactions, ito. If we have concurrent reactions, okay, take note, that beam will be unstable. If we have this, okay, as you can see, the direction of the reactions are all upward. You have parallel reactions. If you have parallel reactions, that makes the beam unstable. So if you are to design reactions or if you are to place supports on your beam, avoid concurrent reactions and parallel reactions. That makes the beam unstable. These two, concurrent and parallel reactions, are considered as improper constraints. Alright, so that is for B. We proceed to stability and determinacy of truss. Okay, always remember that the basic shape for the stability of truss is triangulation. So make triangles. Okay, so we have for truss and its corresponding criterion. The corresponding criteria. So a truss is to be unstable if the number of bars plus the number of reactions is less than twice the number of joints. Then we have determinate truss. A truss is said to be determinate if the number of bars plus the number of support reactions is equal to twice the number of joints. Then we have indeterminate truss. Indeterminate truss, if we have the number of bars plus the number of support reactions is greater than twice the number of joints. So determinate and indeterminate are said to be stable trusses if we don't have a problem when it comes to their geometrical shapes. So we have, again, the equivalent of B is, we have the number of bars in that truss. We have R, a number of support reactions. And we have the J will be the number of joints. Okay, so let's have one example. Next example for the stability and determinacy of trusses. Okay, for example, we have the first one. So we have on the left side, we have a hinge support. So we have horizontal and vertical. Again, this is a ruler. So this is a one support reaction. So we have the number of support reactions, external support reactions, we have 3. Then we have the number of bars. How many bars do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you have 13 bars that compose this truss. Then the number of joints. So we have 1, 2, 3, 4, 5, 6, 7, and 8. So the number of joints will be 8. So all we have to do is satisfy the value, the number of bars, the number of reactions is less than, equal to, or greater than twice the number of the joints. So we have the number of bars is 13 plus 3 is, obviously this is equal to twice of 8. So we have 16 is equal to 16. So this is considered to be a determinate truss. Determinate truss, for a reason, determinate and at the same time stable. Determinate and stable since it can strain or it can resist vertical and horizontal forces. As you can see, every panel is a shape of triangle. Then next we have number 2. So how many support reactions? So we have hinge or 2 hinges. So the total number of reactions will be equal to 4. How many bars are number of bars that compose this truss? So you have 1, 2, 3, 4, 5, and 6, 7, and 8. Your number of bars to be 8. How many joints? We have 1, 2, 3, 4, 5. Can you observe this part if it is a pass-through or it is considered to be a joint? If it is pass-through, then neglect as joint, not counted as a joint. So how many joints? We have 1, 2, 3, 4, and 5. So I think this is 8. The number of bars plus the number of reactions, we have 4. I think this is greater than twice the number of joints, 5. So this is 12 is greater than 10. Degree of indeterminacy, indeterminate. This truss is indeterminate. And at the same time, stable, we don't have a problem. Its geometrical shape is indeterminate to the second degree. Alright, so that is 12 minus 10. Degree of indeterminacy, we have second degree. We need 2 additional equations to compute all these unknowns. Axial forces, support reactions. Then we have number 3. How many reactions do we have? This is a ruler, another ruler. Ruler support, ruler support. And the number of support reactions is we have 4. Then we have, how many bars do we have? Okay, unahin natin yung mga horizontals. 1, 2, 3, 4, 5, 6. 6 horizontals, vertical. 1, 2, 3, 4. For vertical, that makes it 10. Then yung mga inclined or slant, we have 3. So that makes it 13. Tama ba? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Then we have how many joints? The number of joints, we have 1, 2, 3, 4, 5, 6, 7, and 8. So I think this will be great. The left side will be greater than the right side. This is 13 plus 4 is greater than twice 8. So we have, this is 13, that is 17. This is 17 is greater than 16. So can we consider this one as indeterminate when it comes to the number of unknowns is greater than the number of possible equations? Kaya lang, one problem is, again, we have this parallel support reactions. If we have this case, if we have parallel reactions, all of these supports are a ruler. If we are to apply a horizontal force, this truss will obviously move to the right. That makes this truss unstable. Okay? It is unstable. So, ano yung pwede natin gawin dyan para maging stable siya? For example, what can we do in that truss to make it stable? So, to make it stable, we may replace one of the support, one or two maybe. So, for example, if you are to replace one of its support with a hinge, so let's say this is a hinge, a ruler. Okay, let us check if it is already stable or determinate. We have the number of bars, or unahin natin, how many reactions do we have? Horizontal, vertical reactions for the rulers. The number of support reactions will be equal to 5. Okay, but it is now stable for a reason it can now resist horizontal forces. And the number of bars, pareho lang naman siya, that is 13. We have 13 bars, and the number of joints is the same. We have 8. That makes it 18 is greater than twice of 8, or this is 18 is not greater than 16. Degree of indeterminacy will be equal to second degree, and it makes this truss indeterminate. Okay, indeterminate, and at the same time, it is stable. Okay, it is now stable since if you are to apply, for example, if you are to apply a horizontal force, it can we have a horizontal reaction that will resist that horizontal force. And then, one thing more, if you are to deal with this type of trusses, take note that to make a truss stable, the basic shape of truss is triangle. So for example, in this case, for example, we have a missing member here. Kung tatanggalin niyo yung isang slanting member dito, that makes this truss unstable. Okay, it is unstable for a reason you will be having two parallel members. Okay, they are directly parallel. Okay, we proceed to the stability and determinacy of frames. So we have the following criterion. So we have an unstable frame. Unstable if there is 3 times the number of members plus the number of external support reaction is less than 3 times the number of joints plus C. Then we have determinate frame if 3 times the number of members plus external support reactions is equal to 3 times the number of joints plus the value of C. Then we have the last next one. We have indeterminate. Determinate, there is 3 times the bars or 3 times the member plus the number of support reactions is greater than 3 times the number of joints plus C. We have a unique case here if we are dealing with frames compared to beams. That is, we have C should be equal to MC minus 1. For the cases that we have pin joints or pin joint, wherein M is the number of members. The number of members connected so we have for this case, if you are dealing with frames with a pin connection for joints, so we have the value of C should be equal to MC minus 1. Wherein, again, we are dealing with pin joint. M represents the number of members connected to the pin joints. So let's have an example. So let us check the stability and determinacy of these following frames. So example number 1. Okay, so all we have to do is first determine the number of support reactions. So we have for a ruler, 1 reaction. For a hinge, we have 2. For a fix, we have 3. So how many reactions in all? So this is 1 plus 2 plus 3. We have 6. We have the number of members or bar members of the given frame. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We have 10 bars that compose this frame. Then if you are to count the number of joints, okay, so take note, you have to consider this connection from the support and the truss. So we have 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 joints. All we have to do is satisfy the condition. We have 3 times the bar members plus the number of support reaction is less than, equal to, or greater than 3 times the number of joints plus the value of C of the condition. So we have C is equal to 0 since we don't have an internal pin or an internal ruler. So we have, I think that this will be greater than, this is 3 times the number of bars, we have 10 plus, okay, so we have 6 reactions, and this is greater than 3 times the number of joints, we have 9 plus 0. So we'll be having 36 is greater than 27. So degree of indeterminacy, 36 plus 27 is, we have the 9th, is a 9th degree. And we may consider this frame as also indeterminate. And stable. So usually for frames, they are stable as long as we don't have any geometric instability. And then we have the next one. For this case, we have internal pins. So we have the number of support reactions. So these are fixed support. Automatically, if we have fixed support, we have 3. So 3, 6, 9. So we have 9 support reactions. The number of bars, we have 1, 2, 3, 6, 9, 12, and 15. We have 15 bars. Then we have the number of joints. 1, 2, 3, 6, 9, then we have 12 joints. So we have, this is 3 times 15 plus the support reactions 9. Okay, I think this is greater than 3 times the number of joints. But before that, bago natin makaligtaan, kailangan pala natin yung value ng C. So you have the value of C, pero take note, this is, these are pin connections, but they are not in a joint. So they are just pin connections in a given member. So we have the value of C, so we have 1, 2, 3, 4, 5, 6. The value of C will be equal to 6. And let us satisfy the condition. This is 3 times the number of bars, 15. Support reaction is 9. I think this is greater than 3 times 12 plus 6. So we have, this is 45 plus 9, we have 54 is greater than, 45 plus 54. 3 times 12 is 36 plus 6 is, 36 plus 6 equal to 42. Degree of indeterminacy, 54 minus 42 is, and this is 12, the 12 degree of indeterminacy. So this is indeterminate. At the same time, stable. Okay, the next, for this case, we have a pin joint. Okay, this is a pin joint. So we having the value, our number of support reactions. This is a hinge. We have 2 support reaction, a fixed support. We'll be having 3, another fixed support. So we have 3 support reactions. So the number of reactions will be equal to, number of support reactions, we have 8 support reactions. The number of bars, we'll be having, I think this is 10. Same lang naman siya doon kanina. The number of joints, how many joints do we have in all? We have 1, 2, 3, 6, 9 joints. The value of C for this case, is equal to MC minus 1. So what is the value of M? How many members, okay, how many members are connected in that pin joint? So we have the number of M, we have 3. What is the value of C? That is 1 for a pin. So we'll be having the value of C will be equal to 3 times 1 minus 1. The value of C will be equal to, is equal to 2. So this will be 3 times the number of bars, 10. Number of support reactions, we have 8. Is it greater than? Okay, we have 3 times 9 plus the value of C, which is 2. 30 plus 8, this is now, we have 38. Then, greater than 27 plus 2 is 29. I will be having the degree of indeterminacy. I is equal to, so we have 38 minus 29, that is 9th degree. Then we have, this is indeterminate. And at the same time, stable. So you have, or anyway, you have enough example in your modules, so kindly read them.